This is really hard concentration problems number 2. A solution is prepared by mixing 50 ml of toluene with 125 ml of benzene. Assume that the volumes add upon mixing. Calculate the mass percent, mole fraction, molality, and molarity of the toluene. Okay, the first thing we want to do is identify the solute. That would be the toluene. Then the solvent will be the other liquid, which is the benzene. Okay, they have given us the density of the toluene, and from the density and the volume that's also given, we can figure out the mass of the solution. So the density of toluene is 0.867 grams per ml. We are given 50 ml. Therefore, we know that the mass of toluene that we are dealing with is 43.4 grams. Likewise, the density of the benzene is given, as is the volume of the benzene. The volume of the density of the benzene is 0.874 grams per ml. This time our volume is 125 milliliters, giving us a mass of 109.3 grams per ml. Okay. So we're ready to do our mass percent, which is defined as the mass of the solute over the mass of the solution. That would be equal to 43.4 grams divided by the quantity 43.4 plus 109.3 times 100%. The mass percent of the solution is 28.6%. Okay, now let's do the mole fraction. In order to do the mole fraction, we need to know the number of moles of the toluene equal to the mass, 43.4 grams, times its molar mass, which is 78 grams. I'm sorry, 92 grams. That gives us 0.472 moles. The mole fraction of the benzene, the number of moles of benzene, equal to 109.3 grams. Its molar mass is 78 grams. The number of moles of benzene is 1.40 moles. The mole fraction of the solute is equal to the moles of the solute, 0.472, times the number of moles of the entire solution, 0.472 plus 1.40. The mole fraction of the solute in this solution is 0.252. Okay. Next, let's solve for the molality. Molality is equal to the moles of the solute over the kilograms of the solvent. We have determined the number of moles of the solute to be 0.472 moles. Earlier, we figured out the mass of our solvent is 109.3. So that is 0.1093 kilograms. The molality of this solution is 0.432 molal. Finally, we can figure out the molarity of the solution, which is equal to the moles of solute over the liters of solution. The moles of solute, 0.472 moles. The volumes of the solution were given earlier in the problem. The volumes of the solution would be the volume of the toluene, the solute, plus the volume of the benzene, 125. That would be 175 milliliters, or 0.175 liters. The molality is 2.70 molar.